Method number 2 is called square roots. How do you know when to use method 1 versus method 2? We'll tell you when we get to the end of all the methods. Right now, we're just practicing what they are. We'll figure out which one's the best one later. What are the zeros of x squared minus 16? That's the same thing as saying solve. It's the same thing as saying what are the x-intercepts. I could say what are the zeros, what are the roots, what are the solutions. All means the exact same thing. It means solve. Step number 1, isolate x squared. Take the square root of each side. Step 3 is the most important, so I'm going to do it in red, because if you're going to make a mistake, this is where you're going to do it. Don't forget plus/minus. Remember we talked way back in Unit 2 that when you take the square root of something, it can be plus or minus? And we talked about 3 times 3 is 9, and negative 3 times negative 3 is? So if I said, what's the square root of 9? Is it 3 or is it negative 3? That's what this means, and I'll talk about this again when we get to the example. Step number 4, solve for x. No, beside the numerical value. Good question. Anthony.
If you had to keep solving past where it would say plus or minus 3, and you had to do something flat 3, how would you do that?
You would split it into 2 equations. You would say x equals 3, x equals minus 3, and go from there. That'll come a little bit later in this unit. Going to our paper. Example 5, because it's just continuing on with the methods from yesterday. Isolate the x squared. Check. Step number 2, square root both sides. The purpose of the square root is to do what? Get rid of the squared. It's the only way to cancel out a squared is the square root, so we know this just leaves us x. Grab my red pen. This is that important step number 3. What's the square root of 16? Well, it could be plus 4 or it could be minus 4. So we're lazy and we just write those together as plus minus. And then we have 4. What that means, and some people like to write it out this way, is there are 2 solutions. The first one is negative 4, and the second one is positive 4. So if your brain likes this better, then feel free. You don't have to do this notation. It's just a lazy way of doing minus 4 plus 4. I could have chose this by factoring. This is almost close to the x squared equals 4 that we did earlier. I could have taken the 16 over. I could have done my difference of squares. I could have split and solved it. Just this took 2 steps. That would have taken 4. So it's not that one method won't work and the other one will work. It's just which one is going to save you time in the long run. 2x squared minus 1 equals 5. Step number 1, I want this x squared all by itself. How do I get rid of the minus 1? How do I get rid of the 2? And now we're right back up where we were at the beginning of this one. So now we're going to square root each side. What happens when I square root an x squared? Cancels just leave me x. Plus or minus has to go in front. And what the heck do I do with root of 3? Yeah, is it a perfect square? Was it like 16 up here that I can get a perfect square root out of it? So we just leave it. That's the answer. What are the values? And again, you don't have to write it this way, but x equals negative root 3 and root 3. Which is about 1.6 and negative 1.6. So you might want to make a note if you can't do the square root, just leave it. We don't grab our calculator. There's no point. This is still a value. I don't need to know the decimal value of it. X minus 4 squared equals 12. Find the x-intercepts. What the heck does that mean? Same thing as solve, same thing as find x, same thing as find the zeros, or find the roots, or factoring. They all mean the exact same thing. Common mistake for this one is people are going to want to add 4. Can we do that? Why not? Because of BEDMAS, and BEDMAS says that exponent takes precedence over the subtraction, so we can't just add 4 to both sides. Well, what do? I need to cancel this squared. So how do we cancel out a squared? We square root. The reason I didn't FOIL it is because I want to cancel that whole squared, and the only reason to do it is to square root. So this is going to leave me x minus 4. The other side, that plus or minus, is going to go in front. And then what do I do with root of 12? Is that a perfect square? Oh, but can I simplify it? Hello, unit number 2. How do I simplify it? What, you mean the units have things to do with each other? That's crazy.
You could do 3 on the outside.
And then what happens with my 2 squared and my 3? So 2 is going to go up front. Root 3 is going to stay behind. Are we okay so far? How do I get rid of a minus 4? And when I add 4 to this crazy side, can I add 4 to a root? No, so I'm going to stick it in front. So I'm going to say 4 plus or minus 2 root 3. And I know to you that looks really, really weird. To me, those are numbers. And they're values, and we're fine with that. If you don't like those notation, you can split it. So this is 4 plus 2 root 3 would be the first answer. And then 4 minus 2 root 3 would be the second answer. I know this looks really weird. To me, it's a number. This is approximately 1.6 times 2 plus 4. That's a numerical value. That's it. That's method 2. No exceptions. It'll work every single time. I like it. If you're not into factoring, this is a really nice method. 3 or not 3? 3. Called completing the square. I'm going to pause momentarily. I'm going to go way back to grade 9, and you're just going to watch. You don't need to write this down. But do you remember algebra tiles? Do you remember that you hated them?
Yes.
Yeah, we did too. But let's say I gave you something like this. And I said, oh, you can't even see that. And I said, I want to factor this using algebra tiles, but I don't know what number I need here to factor. And so we would have set up the little grid, remember this? And we would have drawn one big square, and we would have put it colored. Why? X squared. If you don't remember algebra tiles, you don't need to know them. I'm just showing where the name's coming from. And then I would have needed 6x, so I would have split it, and I would have put 3 of them here. And 3 of them here. Remember that? Again, you hated them. I hate them too. And then we would have had to fill this in order to be able to factor it. And so what I'm doing is completing a square by finding how many little squares need to go here. So I would have one little square here, and would it be colored or white? Colored, because color times color make color, and I would have another little one here, and another. And how many in total would I have to fill this in? I would need to have, and let's just pretend I colored them all in because I'm lazy at the moment. Okay? That's why it's called completing the square, because graphically what you're doing is completing a square. And so then we would have said, well, this is a dimension of x, and this is a dimension of 3, and this is x, and this is x plus 3. So this factors into x plus 3 squared. Okay? Kind of remember that from grade 9. If you don't, that's okay. With me? Well, this we like because this is method number 2. If this was equal to some kind of number, how would I get rid of the squared? Square root, and then how would I get rid of the 3? I would take the 3 over. So this is what we're trying to do, is make all the questions look like method 2. How do we do that? It's called completing the square. If I can make them look like method 2, then I can use method 2, which you've just seen isn't bad compared to factoring. That's what completing the square is. The problem is, this will not form a square. If I were to draw my x squared, and I were to split my 10 bars, I would have 5 and 5. So again, you don't need to draw this, but way back, this is where the name's coming from. I have my x squared, I have 1, 2, 3, 4, 5 bars, I have 1, 2, 3, 4, 5 bars to make 10 bars. How many little squares would I need in here? I would need 25. This question has only given me 3. You still with me so far? So what I'm going to do is I'm going to fake the question out and I'm going to cheat just momentarily. Okay, it's called completing the square. Method number 1, or step number 1, which isn't going to make sense till we do it, so don't panic. First thing is move all x's to one side. Semicolon, because I kind of enjoy using a semicolon. I don't even know if I'm using it right, but go with it. Move all x's to one side. The coefficient of x squared has to be 1. Coefficient of x squared has to be 1, and I'll show you in a second how to make it equal to 1 if it's not. This next step is going to seem weird. Just go with it till I show you the example. Calculate b divided by 2 squared. Calculate b divided by 2 squared. Add this value to both sides. Step 3, factor the left-hand side. If you don't like my abbreviation there, write out left-hand side. Comma, simplify the right-hand side. Yep, that's whatever makes sense in your head. Factor the left-hand side, simplify the right-hand side. Step 4, square root both sides. And I'm just going to make a note at the end of that. Don't forget your plus minus. Five, solve for x. So step 4 and 5 is method number 2. The purpose of steps 1, 2, and 3 is to make the question look like method number 2. That's why we put these together, because it really is following method 2. It's just kind of being sneaky about it. Again, I know the steps are weird because you've never seen this before. Just go with me. There's going to be no exceptions. It's always going to work.
So method 2 is the square root.
Correct. Step number 1 is I need all the x's together. I need anything that's not an x away onto the other side. So I can keep my x squared, I can keep my 10x, it's that 3 that's got to go. How do I move a 3 to the other side? What's the opposite of adding 3? And you notice I'm leaving a space there. I'm leaving it for a reason. Questions on step 1? He should have talked yesterday about what's called the general form of a quadratic, which is ax squared plus bx plus c. Did you talk about that? Okay, and this is the same as y equals mx plus b. That's where it's coming from. All we're doing is labeling the coefficients. So when we talk about them, I don't have to say the coefficient of x. The coefficient of x we call b. The coefficient of x squared we call a. So step 2, when it says calculate b squared divided by 2, what that means is the coefficient of x. Take whatever is the second value, the one attached to x, we're going to divide it by 2, and we're going to square it. So I'm just, for the moment, just going to deal with that negative 10. I'm going to divide him by 2. I'm going to put some brackets around him, then I'm going to square him. What I'm doing by that little calculation is figuring out the amount of squares in here. The dividing by 2 is because I split the x into 2 equal parts in this, and the squaring is because I'm figuring out the area that goes here. So in this case, we already know just by looking how many little squares are going to fit in here. 25. That's coming from 10 divided by 2 is 5. 5 squared is 25. That's what this little formula is doing. Brackets come first in BEDMAS, so that becomes negative 5. Negative 5 is equal to 25. Negative 5 squared is equal to 25. All I'm doing is just with a little formula calculating how many of those little squares, because I'm completing the square. I'm putting how many little squares I need to make a square. Anthony.
Could we just skip from minus 10 divided by 2 squared to 25?
Yep, absolutely. And so what I'm going to do to make this look like method 2, I'm just going to add 25 to it. I'm faking out the question. I'm like, you need to be 25? I'm going to make you 25. Can I do that mathematically? Sure, as long as I do what to the other side? Add the exact same thing. I can add any number, any variable, any term I want to the left-hand side as long as I do the same on the right-hand side. So what I'm kind of doing here is just faking out the question to make it look like method 2. I'm going to take the left-hand side, I'm going to factor, and this will always be a binomial squared. It will always end up being something like this squared, because I've picked the number that's going to make that. X squared is always going to give me an x, and if you don't want to do a lot of thought about your factoring, the middle divided by 2 will always give me the second number. What's negative 10 divided by 2? And that just comes from we took the bars and we split them into 2 equal groups in the diagram. Or you can think of what's the 2 numbers that multiply to give you 25, add or subtract to give you negative 10. What multiplies to give us 25? 5 and 5. How do I make negative 10? I make them both negative. Questions so far? I'm just going to simplify the right-hand side. I'm just going to take my negative 3 that was there, my 25 I added on, make it a little bit simpler, which will be 22. We're now at method 2. This was the last example of method 2, looked exactly like this. Method 2. Method 2 is get rid of that squared. What's the only way I have mathematically to get rid of a squared? Square root it. On the left, that squared cancels, so it just leaves me x minus 5. What do I have to write on the right-hand side? Plus or minus. Can I evaluate the root of 22 evenly? Can I simplify the root of 22? So what are the factors of 22? 1 and 22. 11. 2 and 11. Are any of those perfect squares? So I just leave it. It's just root 22. That's a number. I know that's bigger than 4, less than 5. I don't care exactly what number it is. Last step is just to isolate this x. How do I get rid of a minus 5? And where do I tuck it when I got all this crap on the other side? In front. So 5 plus or minus root 22. That's the final answer. Crazy, I know. The purpose of method 3 is to make it look like method 2. That's the whole reason we have method 3, is to make it look like 2 so we can just square root both sides. The nice thing is those steps are not going to change. There's no exceptions. They're going to work every single time. Step number 1, everything with an x stays, everything without an x goes. So that minus 1, we need to boot them to the other side. How do I get rid of a minus 1? Oh, thank you. There is a little negative in there I didn't even see. How do I boot this negative 1 over? How do I get rid of him? Now the second part of step 1 that we haven't done yet talks about this coefficient, which is the a value, we call it. The a value has to be what? 1. So I need to make this number 1. What's the opposite of timesing something by negative 1/2? How do I cancel it out? I want to times everything by negative 2. And if you're like, whoa, what just went on there? If we look at just this, and I just multiply this, I end up getting negative x over 2. And so what's the opposite of dividing by 2? Multiplying by 2, and then to get rid of the negative, I'm going to multiply by negative 2. That's why I'm doing it, because it's really like a division. Okay, negative 2 times negative 1/2. Just showing you over here what's happening. This is really over 1. So top times top. Two, bottom times bottom. 2, and what's 2 divided by 2? And that's what I want over here. That's why I'm doing it. So I'm going to have 1x squared, which we don't need to write the 1. And algebraically, if I do it to 1, I got to do it to everything. So I've got to do negative 2 times 6x. And on the other side, I've got negative 2 times 1. I'm just going to pause there, and you can ask me any questions you want to ask me. So I could have chose to bracket this and just put it once, but then just distribution says I would have had to multiply it by every term. Because right now it's negative 1/2, and I need to be equal to positive 1. So what do I multiply to get positive 1? Negative. Any other questions you're not sure of? A always has to be 1. Until next unit, when that's a big lie. But for now, it has to always be 1. Anything else you're not sure where it came from or why we're doing it? Here or here? I'm just showing I'm multiplying everything by negative 2. Now we're on step 2, and we're going to fake out this question, and we're going to do what's called completing the square. Completing the square is we take that middle number, we divide by 2, and we square it. Negative 12 divided by 2. Don't everyone shout at once. Negative 12 divided by 2. Negative 6. Negative 6 times negative 6 plus 36. Okay, so that's coming from negative 12 dividing by 2 and squaring. And the only trick to this is if I add it to the left, what do I have to do over here? I need to add it to the right. The whole purpose of that 36 is to make it look like method 2. I'm going to simplify the left-hand side, factor the left-hand side, simplify the right-hand side. My left's going to turn out to be a binomial squared. If you don't want to have to think about the factoring, it's always middle divided by 2 gives you the number. If you want to think, you're looking for product of 36, sum of negative 12. What's the only two numbers that multiply to give us 36 and add or subtract to give us negative 12? And on the other side, I just need to combine the negative 2 plus 36. Brad, question or just a stretch?
I had a question.
Yep.
What if at this step you get a negative number, like say if it was negative 34,
That's fine.
would you still be able to square root of it?
No.
So would there be no answer?
Correct. Other questions? Yeah.
How do you know that it's supposed to be like
Bracket like square root. You lost. How do I know it's this? Because I'm picking the number that's always going to make it look like this. You can write it out as 2 brackets, okay, which is x and x. And then product of 36 has to be negative 6 and negative 6. But what's negative 6 times itself? Right? What's the binomial squared? I'm just simplifying it out. It will always turn out to be like this because I picked this number specially to do that. Now we're in method 2. Method 2 says get rid of the squared. How do we get rid of the squared? What has to go in front of your square root on the right-hand side? Can I take the square root of 34? Can I simplify the square root of 34? Okay, so factors are 1 and 34, 2 and 17, which is prime. Nope, so I just leave it. Last step is get rid of this minus 6. What's the opposite of subtracting 6? And where do I tuck it when I got all this mess over here on the right-hand side? Just in front. Questions so far? How you feeling? Same steps every time. They're never going to fail you. There's no exceptions. Why are you two smacking each other like you're 5 years old? Seriously, what is going on over there? Step number 1, everything with an X stays. Everything without an X has got to go. So all of this X stuff is good. The 5's got to move over. How do I get rid of a 5? Now there's that second little part of step 1 that says I need to look at the coefficient in front of the x squared. We call it the a value. What does the a value have to be? It is not 1 right now. It is 3. How do I get rid of 3, or how do I make it 1? And if I divide it by 3, I got to divide everything by 3.
Could I just put like a giant?
Yeah, you can put it all the way over. That's fine. So the first term is going to leave me with x squared, which is what I want. 9x divided by 3. Negative 5 divided by 3. Just leave it. Can't divide it? You don't. You just leave it. It's a fraction. Oh well, we'll deal with him when we get to the right-hand side. Questions? Now we do what's called completing the square, which is when we put in that special number and we add it to both sides. How do we find that special number that we have to add on to complete the square? B divided by 2 squared. You might want to grab your calc if you don't want to do the fraction work. So 3 divided by 2, 1.5. 1.5 squared. Offer of 2.25. And just tell me, where did that number come from? Just so we look back, we know where it... I did 3, and then what did I do with it? Divided by 2 and squared. And if I add 2.25 to the left, what do I have to do way over here to balance it? Add 2.25. I factor the left, I simplify the right. The factoring will always be a binomial squared. I just need to figure out what's this number in the middle. If you don't want to do the thinking, take the middle and divide by 2. What do I do with all this crap that's over here? Plug it into your calc. So do negative 5 divided by 3 plus 2.25. Sorry, point. Confirm that number. That's why we do it on my calc, because I don't want to do that by hand. I don't want to do that much thinking. That sounds confirmed. Okay, don't worry, it's a decimal. It's just a number. We'll carry on. This is now method 2. What do we do for method 2? Square root both sides. What happens on the left? What happens on the right? Almost. Gotta have that plus or minus. Now, you can evaluate it if you want to, since you have your calculator. If you don't, you can leave it as a root. It's completely up to you. Since we have our calculators, let's just calculate the root. By we, I mean you, because I don't have mine.
Oh, I said it's 0.763766.
Can I put 763 dot, dot, dot? Again, that's a choice. You can absolutely leave it as the root, 0.833 repeating, whatever it was. It's just we have our calculator, so why not? What do I do with this 1.5? Because we have our calcs, we could go one step further and actually get the final answers, but you don't have to. You can leave it like this. But if you wanted to do negative 1.5 plus 0.76, and then you would do negative 1.5 minus 0.763, we're happy here. These are numbers. They're solutions. They're roots. There's x-intercepts. Anthony?
Technically, wouldn't the root of 0.583 repeating be more accurate because it has the
But I've put the dot, 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 so I haven't rounded. If I rounded, then yes. But because I've just kept it, we're okay with that. Good question.